Today we are going to solve
नहीं
very
मार reference.
Hi everyone, hello. I hope all of you are doing well. My name is Riya Bansal and I'm currently an educator at Free Level. And today we are going to solve a very interesting problem known as alien language. So first what we're going to do is we are going to look at the problem statement, see what it basically expects us to do. Then we are going to look at an optimized approach to solve this question, followed by the implementation and code for this problem. Okay, so first let's take a look at the problem statement and see what it expects from us. So if you will see the question on the screen, the question says that there is an alien or a group of aliens rather that started their journey towards the earth. Now they somehow mastered our English language through a dictionary. Okay, now however they don't want to use that language and they want a new language, right? Which is basically nothing but consisting of the same 26 alphabets, but they have been shuffled in a different way. Okay, so what we understand as a language for English is that A comes first, and then B is the second character, then C is the third character, then D is the fourth character, E, F, and so on, right? Now, they also used the same characters to create a new language, just that the characters have been jumbled, okay? Now, what they want is they want us to learn their new language, which is basically nothing, like I said, English only, but the characters have been shuffled. So the problem statement is that to actually test whether you or as us as humans have actually understood that or not, right? They have a test for us. We have been given cue words, okay? And we need to basically sort them by following the new lexicographical ordering, okay? Lexicographical ordering basically means dictionary ordering, right? For example, if I have two words in our English language, for example, an apple and a banana, right? Apple comes first because that's how it is defined, that A is a smaller character or a character which comes, I would say, earlier in the dictionary compared to B, right? So apple is going to be appear earlier in the dictionary compared to banana. That is why A is going to be smaller, or apple is going to be smaller than banana. Okay, so that's how the ordering is defined. Now the aliens will give us their knowledge or their way of understanding the characters, their ordering of characters, and they will also give us a set of words. Okay, they will give us cue words, and basically we have to tell what is the right lexicographical ordering for those cue words. For example, you can see the input on the screen. There is S as the ordering, where B is actually the first word in the dictionary, then A, then C, then D, E, F, G, H, and so on. Okay, and the cue words given to us are AA, BA, BB, right? And then the output for this and the lexicographical ordering for this is going to be having the BB in the output first. And why is that? Because if you see the ordering, B actually appears as the first word, correct? And hence that is why BB as a word will appear first in the dictionary compared to the word BA, right? So when you see that the first characters for two different strings are same, then you compare the second characters. Now, although BB and BA has the same first character, right? Then we try to differentiate them based on their second character, which is B and A. Now, since again, in the aliens language, B is smaller, that is why B appears first in the dictionary. Okay, and that is why in the output also, in the lexicographical ordering also, BB will come, then BA will come, and then AA will come. Okay, so that is what is the problem statement for us. We will be given an input string, we will be given a value of Q, and then we will be given Q words for which we need to define the correct lexicographical ordering as per the aliens language. So as a part of the input, we will be given a few test cases. So we will be given T test cases over here, right? And the first line of each and every test case will be a string S that consists of 26 characters, because we need to know the ordering of all the 26 characters in the aliens language. Then we will have a value of Q, that means the number of words that we will be getting as an input, and followed by that we will have Q, I would say, strings, which are going to be the input which we need to provide the lexicographical ordering for. And in the output, we just have to provide a final array which consists all the words in the correct lexicographical ordering. And the constraints of the problem has also been given on the screen that you need to keep in mind while optimizing the solution for your problem. Okay. If you want to take a look at the sample input, here 1 denotes the number of test cases, so we only have a single test case. B, A, C, D, E is again the ordering or the language which the aliens understand. 3 is the number of words that you need to sort, and then the words are BB, YB, and ZA. Okay, and based on that, we can see the corresponding output as well. BB would come in the output first because B is the smallest character or the earliest character we understand, followed by ZA, right, and then a YB. Now ZA, if you can see, the third last character is Z in the input and the second last character is Y, right? And hence the ordering has been defined in a similar way, and this is how we get the output. Okay. Now with this, I hope the question is clear to everyone and there are no issues or any doubts about that. Once that understanding is clear, now we will move ahead to see what is the solution for this problem. Now, if you will see here, if this question would have been a very simple question where you have been given a set of words, let's say AB, AC, AD, DE, and BE, right? And the understanding is a simple human language, then we could have simply sort all these elements, right? And then we could have get the final answer, which would have been, let's say, AB, right? Followed by AC, AD, BE, and DE, right? But unfortunately, we have to arrange all the elements in the lexicographical ordering as per the alien's language, right? So for that, what we have to do is, when we are comparing two set of elements, right, to define which one will come at the first position, or rather all the positions in the final output, we have to keep in mind the ordering in which the alien language has been defined. Okay, because based on the alien language only is the way we are going to compare the elements, right? So the game here or the task here is to define the comparison of two different strings in such a way that the comparison is basically done based on the alien's language and not the English language that we know of, right? So to make that task very easy, first what we will do is we will store all the orderings of the alien language in a hash map or an object kind of a structure so that it's easy to always look at what kind of ordering or the final lexicographic ordering is required. Okay. For example, let's say the ordering is something like this: B, C, D, E, or let's say Z, right? F, G, so on. So what we can do is we can define a hash map structure where the ordering would look something like this: that B is the first character, okay? Then C is the second character, D is the third character, E is the fourth character, Z is the fifth character, and so on, right? So what this will help us is we can easily see that if I have a current character, let's say Z, I easily know that what is the defined ordering for this particular character. So that's the purpose that we are trying to solve here. That given an input string, we will try to store all the ordering as per the alien language over here for each and every alphabet. Okay. Now, once that is done, we've actually done almost half of the part for this question. The rest of the part that we will be doing over here is that now we will iterate over all the Q input words given to us. Okay. For example, let's say here the word given to us is, let's say, BD. Okay. So for this, using this hash map, we can kind of convert this particular input string into numbers, right? Because that will make the comparison very, very easy. For example, if I have BD over here, I can just simply say that the corresponding number in the alien language for this is 13. Why? Because B corresponds to 1 and D corresponds to 3. Correct? Similarly, if I get CZ, then what I can do is I can say that the corresponding number is 25. Why? Because C is 2 and Z is 5, right? If I would have directly compared C and Z, it would have been a tricky task to do, right? Why? Because here BD and CZ are not directly comparable because the language is different. But once we have converted those into the numbers as per the alien language, we can easily see that BD is smaller. Hence, in the final output also, BD will come before CZ, right? So that's how we are going to simplify the problem. For all the input words that have been given to us, right, we are going to find the corresponding number for all of them. For example, here if I have BC, then we have DE, right? And let's say I have BZ, okay, or CC, and let's say BD over here. Now we will define the corresponding, I would say, numbers for each and every input string. So for BC, it would be 12. For DE, it can be 34. For BZ, it would be 15. For CC, it would be 22. And for BD, it would be 13. Right? Now, once we have this kind of ordering present, now the task is actually very simple because the question has now been reduced to simply sorting these numbers. Correct? Which is actually a very easy task to do. Right? Now, what we will do is that we will arrange these numbers, which is 12, 13, 15, 22, and 34. Right? Once you have sorted this, your task is done. Right? 12 was what? BC. 13 was what? BD. 15 was what? BZ. 22 is CC. And 34 is DE, which is indeed the right answer as well for this kind of ordering over here. Okay, so this is a good logical explanation for this. The question actually expected us to sort a simple array, but by defining a different type of way where we are comparing the elements, right? So this makes the task very easy because in the end we have reduced the problem to actually a problem where we just have to, compare certain numbers. And comparing numbers and sorting them is a rather easy task compared to having a different sort of language for each and every input and then sorting base strings based on that, right? So I hope this explanation helps and helps you to understand what exactly are we doing over here, right? In terms of how optimized the solution is, you can see that the very core idea of this problem is sorting, right? And even for the best sorting algorithms that we can think of, n log n is the best solution that we can go ahead with, right? So that's what we are going to do over here. We're going to take this any input test case that has been given to us, right? And the entire set of strings are going to be sorted, right? The entire set of strings are first going to be converted into a numeric format, and that numeric format is going to be sorted. So all in all, the time complexity for this question is going to be n log n because we make use of sorting, and the best sorting algorithm that can work over here is in a complexity of n log n, right? So that's what we are going to do a look at. Now, I hope this explanation helps and you get a good idea of how it works. Next, we are going to take a look at how the implementation for this problem would work. Let's take a look at the implementation for this problem. So we are going to be defining a function, okay, which is basically going by the name Allien Language, okay, that will take the input of the language which Allien understands along with the input of set of strings which actually needs to be defined in the ordering that we require. That is the lexicographical ordering. Okay, so we're going to follow the same steps that we followed earlier to reach to the final answer. Now, once we have the entire logic written over here, then the task is very simple to simply call this Allien language function, right, and pass the input set, which we can just copy from here only, and then we are going to provide the set of strings. You can take any set of strings you want. Let's say I am taking BB over here and then AB over here, okay, and then AA. This is just to test your input. Now the function is basically going to return us a sorted ordering of the elements. So I'm just going to log out that output on the screen to see if we did the correct job or not. Now let's come back to our logic and move step by step, okay? So here what we are first going to do is, first we are going to do that mapping, right? for the input language that has been given to us, all of the input needs to be mapped to a particular number, like we talked about, right? So that it's easy accessible. So for that, what we will do is we will first, there is one whole input string, right? We're going to split it into an array. So for that, we will do lang dot split, okay? And split is like this. So what this will basically give us as an output is this, like B, okay? Then it is going to give us A, okay? Then it is going to give us C. So it's like the input string, which was one whole string, is now divided into an array of characters, okay? And so on. Now, once we have this, what we are going to do is we are going to apply some operations. So I'll do language array dot map, which will give us another array in which we are going to go over each and every character of the array, which will be mapped to the item variable, and then we will also keep track of the indexes. Okay. Once we do that, what we are going to do is we are going to create a language object here as well. Language object, which is like the hash map which we were talking about. So we will have this language object, and each and every, I would say, string would basically become like this, and this is index +1. So we'll just keep on incrementing the value over here. Okay, so this is basically that. Let's see what we have just for your visualization purpose to see what we are working with over here. Okay, so you can see very clearly on this output screen over here that we have defined the right mapping, right? B is mapped to 1, A is mapped to 2, C is mapped to 3, and so on, right? So far we are good. We've defined the hash map. Now let's go to the next part. Once we are done with this, right, the next part is going to be that to arrange or find the corresponding numbers, right, for each and every input string over here. So this is my input string. I'm going to start a mapping over here, where for each and every input string, I'm going to do some operations. Now first, let's say I again take a number like this, okay? Now each and every input again will be split the same way we were splitting the, I would say, the language, right? Each and every input string will also be now split, and then on top of that, each and every character on it will be mapped to a particular value, which is num plus equal to language object of each and every letter. Okay, so what we are doing is, let's say if the input string is BB, okay, so let's say if the item is BB that we are considering, okay, then first we are splitting it. So when we split it, you again get something like this, B and then B, right? Now after that, you have the language object. Now you are considering the value. So for this B, the value was 1, right? And for this B also, the value is 1. So the corresponding num over here is going to contain 1, 1. Okay, so that's how we are trying to define and find the corresponding number for the input string. Okay, once you define this, we can take another, I would say, array in which we are storing all this. So this will be like this. Okay, and here what we can do is we can do letter num dot push, right? Num is basically kind of a string right now. We are going to convert it into a number, okay, because we have formed a number over here, and then store it. Okay, corresponding to that, we also need to keep a mapping, right? Now we know that 1 1 is a number, okay, but 1 1 is a number, or 11 is a number for the string BB, right? So we need to maintain that ordering also. So we can create an object for that. Let's say we do unsorted object. Okay, because we also need to know that 1 1 is mapped to BB, correct? So For that, we will do this over here. Okay. And this we are going to store at 12. So unsorted object, we have parsed the input. We have taken num. Okay. And then along with that, we have the item. Okay. Now let's see for our purpose if we are good so far or not. Let's try to print unsorted object also and see if we got the right output or not. Now see, here we have the right output, correct? BB is mapped to 1, 1, AB is mapped to 21, and AA is mapped to 22, right? So far, so good. And letters num over here is just having these numbers, 11, 21, 22, okay? Now, once we are done with this, right? Now the next part is to actually sort this. Now for sorting this, we have a already defined function in JavaScript, which is dot sort for any array. And we just define the way we want to compare the elements. So we want to do a ascending order arrangement. So I will do A minus B. Okay. And this will basically sort all the values. Now, once we have the letter to number array, which is sorted, now I just need to map those values or the numbers to the actual string that they represent. So I will create a sorted array. Let me create that. Create a const sorted array, which is the final output that we will have. And here in this, right, what we are going to do is I'm going to push the unsorted object, okay, and the corresponding item for that. So I'll go to each and every number of the letter to number array, right? And I'm going to see what is the corresponding value. Okay. So let's say in the output, we got 11, right? But we need to know that for 11, the string was BB and BB should be added in the sorted array. And in the end, we will just return the sorted array. Okay. I think this should do the job for us. Let's see. And see, we do have the required output. Correct? We have BB, which is the smallest string. Then we have AB and we have AA. So this string or input was actually sorted. We can try out a different as well. BB, YB and ZA. BB, YB and ZA as a different input. And for this, we have BB, ZA and YB. And this is BB, ZA and YB. So we have actually passed the basic test cases. That means our solution is indeed correct and it does satisfy what we really expected us to do. Okay. So I hope this is clear to everyone and you get a fair idea on how you need to solve this question. And I was helpful in making this question a little bit easier for you to understand. So thank you so much for attending this and I will see you in the next question. Bye.